Today, I will talk about general ability for autonomous driving. I'm EBL, I'm a CEO, co-founder at IC. Specifically, I will hint at why IC is pioneering autonomous yacht truck space. So before I started the company, I was at MIT, working with my co-founder, Chris Baker, and Professor Josh Tenenbaum at MIT Brain, Machine, and the Cognitive Science Department. So, and what we do is build a machine that can learn and think like people. So here is an example. What we're trying to do is to replicate this 18-month-year-old trying to do here. So he's with his mom, observing an adult trying to do something. He doesn't understand, maybe. And look at what he does. He's approaching the cabinet, open the door, and confirming, did I do the right thing? That is kind of a general intelligence we need, right? But today, think about the robot today. There's a lot of robots applied in the real-world environment in a very complex domain, but most of them are separated from human working space because they don't understand human, and the human don't think they are safe. So think about the future of robotics, autonomous vehicle specifically. We need a system that more like this 18 months old, right? Can really understand the other human drivers, pedestrians in the environment. So at IC, we see this missing piece in this autonomous driving puzzle. So we build a system we call advanced humanistic AI to seamlessly integrate into the human environment. And our goal is to modernize the global supply chain. There are a lot of use cases in the supply chain space. Many people are focused on the long-haul trucking problem. Why? Because it's a very structured environment, right? So if you can do a basic system that can follow the lanes, sometimes changing lane, merging lane, you can deal with 99.99% of cases. You can build a system that engages for hours without human intervention. However, that's not the full story. The challenge, the real challenge, is a long tail of unlikely events in the structured environment. As we mentioned, it's very easy to build a system that follow a lane, changing lane, merging lanes. However, whenever there's a corner cases, like constructions or even cars driving from opposite direction, I don't know whether you have encountered that, you cannot rule out those possibilities, right? Or accidents on the road. Those instances immediately break the structure, and that becomes actually even more of a corner cases in the long tail that's really, really hard to learn and really, really hard to test. So the conclusion is most of the public roads are structured, meaning that there are rules. However, they are unconstrained because there's no physical barrier to really enforce those rules. And the really, really unlikely things can really happen, right? So if you drive millions or even billions of miles. Therefore, the system, the autonomous system, lack of those real experience of the corner cases for perception, prediction, planning, and also lack of approaches to verify and validate such a system because you cannot replicate the behavior of driving opposite direction on the highway, right? What should we do? So a lot of people are thinking about, okay, the ways to do it is to make it more constrained, right? So you can build a lane that dedicated to AV system. Of course, that works. But there's another way to do it, which is make it unstructured, without the rule, no rules. That is IC's approach. At IC, we believe there's a better place to start autonomous driving, which is the logistic yards. The yards are the hubs in the logistic network, like ports, warehouses, logistic hubs, and even real terminals. But it's very different from public road. That it doesn't have the public road regulation, it's private road, it's unstructured, there's no rules, and it's more constrained because the fenced area, you can control who can be there. There's no kids, no wild animals, and everyone wears a greenish safety vest, hard to miss. Also, fewer competitors in the space. However, the yard problem is not easy, right? So as we mentioned, it's unstructured road with fewer rules, and it's congested for most of the time, and therefore the shortage of qualified drivers. Here is a video I took when I first visited our customer site. Look at this. There's no lane lines. There's no traffic lights. When 3 trucks come together, who should go first? So that's not a trivial problem to solve, right? However, the benefit is we have tons of the data that people interacting in multiple ways because there's no rules. So similarly, like we talk about the constructions, like people driving from opposite directions, or like there's some accident on the road that people are moving around the truck. That's all within our ODD, the operational design domain. So we don't miss anything. So the good news is our technology is perfect fit for those challenges. As we mentioned, we spin out from MIT, and what we did is we combine advanced cognitive modeling, game theory, reinforcement learning, and machine learning to build a system can really enable the system learn to negotiate without the rules. So on the left, you can see that is what we simulated a customer yard. The orange colors are the obstacles that you need to avoid. And we simulate a lot of trucks in the different places and do all kinds of random things. So if you pay attention to the in the center, there's 2 trucks that try to negotiate the traffic. So you can see it again. You see they come close together and they try to figure out a way that who should go first. And those autonomous behavior emerges from the learning. And we put such a system in a real application. You can see our truck, they meet each other, and they find, okay, this one side, the aisle is narrower than the other side, so it's better to one yield to another. And all those things emerging by itself. Again, there's no lane lines, there's no traffic lights to regularize the traffic, and it's completely unstructured navigation. And we published a series of papers top-tier conferences, and this is just the tip of the iceberg of what we're doing. But when we put everything together, this is how it looks like. So here, we have autonomous vehicle operating in one of our customer sites. So what's interesting about this video is we ask the driver to step out of the cab. So basically, it's truly driverless. No one in the truck doing anything. The truck is accomplishing the job by itself. It's not just driving. It's also looking for trailers. Basically, what they do is pick up trailer, drop off trailer, pick up trailer, drop off trailer, like a Lyft Uber app, but it's basically doing it with the trailers, right? So after you connect with trailer, it pulls the trailer out of the space, move towards the destination. It navigates through the aisle, intersection, all those cases, and we achieved all the KPIs, including safety and efficiency the customer needed. And I want to mention that this is not a demo, right? So we have already done more than 10,000 moves in customer-side operation on a daily basis. And among those 10,000 moves, there's tens of thousands of encounters of dynamic agent interaction, like the one in the back, interacting with our vehicle in real time. So you can see we're backing in one shot without any back and forth adjustment. And this guy is stopped there and watching, oh, no one in the cab. And after we finish the parking, we disconnect the airline, drop the trailer, and accomplish the move. That just shows you one of the moves. And we have an autonomous vehicle, multiple autonomous vehicle operating in multiple sites in 8 hours full shift, nonstop. And this is our contrarian approach to the supply chain space, where we start from this unstructured, without rules, so that we can build a foundation that can deal with the long tail. And in the future, we can driving the yard outside of the yard, driving the truck outside of the yard, and by building more and more structure on top of it, and deal with more cases. But on the basis, we have this foundation model to deal with all the edge cases that we can encounter in all the crazy ways. And we have the opportunity in the future that play a significant role in the $4 trillion opportunity in the future. Thank you.